Hi grade 12s, welcome to my channel and Merry Christmas. Today is one of those days where you guys should be sitting with your families, friends, and all your significant others, having a whole lot of fun, family time, enjoying, this day together. So unfortunately for, the fanatics of mathematics and physical science, we do enjoy Christmas like everybody else, but we have that edge for learning. So we're going to celebrate our Christmas in style. Just give you a shortish video. It's not going to be longer than 20 minutes so that we do not forget what exactly matters. Yes, this day is good, but what matters is our futures more than any celebration day. So let's have a look and see quickly what can we do. So guys, I'm going to try and give you some work on trigonometric functions so that you can become comfortable with these, because these are easy marks on paper too. Now this is from November 2020. Okay, in the description you will find a copy of this question paper together with this solutions manual, if you want to call it. Now let's jump into it and see the graphs of f. Sorry guys for the background noise, I'm cooking, so yeah, that's the thing. Now the graph of f is equal to minus half cos x. So we already know what this minus half represents. The minus half represents our amplitude, right? And this amplitude is always the inverse of whatever we have as a coefficient. Not the inverse, but an absolute value of that coefficient. So this is literally a half. Okay, good. And what do we learn from this? We know that this value itself gives us our maximum value, which is going to be a half. And then we will have our minimum value, which would be the negative version of it. Okay, of course this is not shifted about. If this was shifted, we then deal with that shift accordingly to get a new maximum and a new minimum. And we know these are the y values at the turning points. Okay, not a problem. And then we see that the angle itself has a coefficient of 1. It means the period is going to be the original period for a cosine function divided by that coefficient. This gives us 360. Now with 360 we will work out our intervals. We take the current period, we divide it by the 4 quadrants, because these serious events take place in these quadrants. And of course this gives us 90 degrees. Now this already tells us that our critical values, the CVs, this is either an x-intercept or an x at turning points. Okay, because the y-intercept itself is not really a big deal in this regard. So we'll explain this shortly. Now let's look at the cosine function. We will see that, of course, cos of 0 gives us a maximum, but now the f function, is this one. But now look at this. The issue was that there's a negative, so this means this graph is reflected about the x-axis. Now it's a vertical reflection. Now it should be starting at a half there, but it's starting over there. So we know that this is minus a half, because cos of 0 gives us a maximum. So this is not just a y-intercept, but a turning point, or a minimum value, This would be minimum. Now look, the x at the turning point is 0. Look at the next x. It's a critical value, which is an x-intercept. It's exactly 90 degrees later. So can you see this is an interval of 90 degrees. And if we keep moving, we will appreciate that at 180, can you see we reach another maximum, so to speak. Okay, this one is a bit crazy, but I'm just going to give it to you guys anyway. So can you see this? What is this distance? It's an interval of 90 degrees. So this is the significance of this. So if we get our intervals, it means we are able to get the shape of the graph by ignoring every other point, but taking note of the x-intercept or the x at the turning point, because these are what will give us the shape of this graph, and we'll get it right every time. All right, okay, all right. Now let's move on to the next graph. So we've got the graph of G. Now the graph of G, we can see that essentially the amplitude is 1. So this means our maximum value is 1, our minimum value is the negative version of that, and these are the y values at the turning points. Again, we can see that the coefficient of the angle is 1, so it means our period is 360 degrees divided by 1, which gives us 360 degrees. And then if we work out our intervals, we will get 360 degrees divided by 4, which gives us 90 degrees. We can see clearly that also this one has intervals of 90 degrees between critical values. But there's more. We notice that there is an plus 30 degrees. Now what does this do? It shifts the graph to the left 30 degrees. This means a critical value that was expected to be somewhere is going to be 30 degrees earlier. Alright? Because in the original function, we know where we expect it to be. But then this one is going to be happening 30 degrees early, or it's shifted 30 degrees to the left. Alright. Now, that's all, guys, we can say so far in terms of just some quick notes. Now let's have a look. Well, if we look at this graph of sine, we know that, okay, at the intercept, it's just sine of 30, because this is 0. So this is going to be a half, which we saw that this was a maximum of the previous function. But now this is just nothing but a y-intercept. Don't really care about it much. We want the critical values. We expect a sine graph to be 1 at 90 degrees, right? But now this shifts 30 degrees earlier, because we can see that this maximum right here is a bit early. So this is going to be 30 degrees early. So 90 minus 30 gives us 60 degrees. Can you see that is where the maximum is? Because the maximum of this function is supposed to be at 1. So this means this is 1. Very important issue, guys, to make sure one understands properly. If you don't work on these graphs with some understanding, believe me, these kind of things will always look strange. But if you have this understanding, you always play with these kinds of things. Remember, in the exam, you won't even need to do what I'm doing. It will just click, because you've been doing it so many times. It will become second nature. It will be effortless for you to do this. Now, not a problem. Now let's see. This was a critical value, right? An x coordinate at the turning point. We can ignore this because it's not a critical value. Remember, the y-intercept depends on what is going on. All right. Now, let's have a look. We come here and we see that we have an x-intercept at 150. Can you see? This is an interval of 90 degrees. Can you see that interval tells us that indeed between critical values we'll have an interval of 90 degrees, and that helps us to get the shape. But let's see, where was this supposed to be? It was supposed to be at 180. Now 180 minus 30 gives us 150. Can you see? This x-intercept was meant to be at 180, but it has shifted to the left 30 degrees. So we understand our graph fully, and we don't have an issue. Now, in the interest of time, we need to read on. Then of course we're told x is an element of 0 and 180, so that's the domain of our graph. Now these are drawn below. Show a with these coordinates 130.9 degrees is 20,33 is the approximate point of intersection of these two functions, and we see there is that point. Okay, great, not a problem. Now let's answer some questions quickly. Now question 5.1 says we need to write down the period of G. Can you see? We've done it. 360 degrees. 5.2, write down the amplitude of F. Remember, we take the absolute value of the coefficient of that function. Okay, so this is 1 mark each. Now 5.3 says determine the value of what is cooking in there. Obviously guys, f of 180 is already 1. I mean, it's a half, we can see there. Now what is this here? For the g function, what would that be? Remember, at 180 we just add 30 degrees. So this is going to be 180 plus 30, which is 210. Now 210 is as good as essentially what did we say? It's 180 plus 30. So if we reduce that, becomes 30, but now that's the third quadrant. Sign is negative, so minus sign of 30 is minus a half. So this is a half, guys. It goes exactly there, minus a half. All right, so we are good. So we know this question is very simple. So if we write f of 180 degrees minus g of 180 degrees is going to be equal to a half minus into minus a half. So this is 1. Very easy. So we're only getting 1 mark for the answer, but everything needs to be clear, guys. See, very easy, guys. You can get these marks in an instant. 5.4, we are then told to use the graph. Now this is one of those higher grade questions, because here you have to be very careful in what you do. Use the graph to determine the values of x in the interval given, for which f of x minus 10 degrees is equal to g of x minus 10 degrees. Now what is the significance of this minus 10? Because obviously these graphs are equal, so we know they are equal at point A, but now we are shifting that point 10 degrees to the left. So this is, to the right, sorry. So for 5.4.1, we know that essentially f of x minus 10 degrees equals g of x minus 10 degrees implies that point A, what am I going to say, guys? Okay. It implies that we're going to have x equal that x coordinate at A plus, remember, when we see this negative here, we will add. It's going to be 10 degrees because we're shifting this to the right. So this is equal to 130.9 degrees plus 10 degrees, which is equal to 140.9 degrees. All right, not a problem, guys. So this is good. This is good. Of course, you don't need to do what I've just done. You could just easily write the answer only, because you look at the mark allocation, it tells us that an answer only is good. But I'm just showing you what is going on, because these graphs are equal at A, but we're shifting this 10 degrees to the right. Yes, on the function it looks as a negative, but in the actual operation we add, actually. All right, not a problem, guys. Very easy question to answer there. So 5.4.2. Now we have a situation. What on the Lord's earth is that? Well, that is something very nice. It's not something to worry about. This is the true higher grade question, actually, if we look at it. But we would not neglect that one because not many students notice these kinds of things during the exam. Now we've got the square root of 3 times sine x plus cos x greater than or equal to 1. If we are going to be using the graph, this means whatever this is, it's either one of these graphs or both of them. Okay, this is what we need to know because we can't use a graph if this is not there. But now this is strange. We don't see, a half cos x. We don't see sine 30 degrees. So what is going on? Now if you look at this square root 3, we should know that 30 degrees is a special angle. Now if we think special angles, we can see that, this is going to be easy. Root 3 sine x plus cos x greater than or equal to 1. Now what are we going to do with this? We can divide by 2. So we have root 3 over 2 times sine x plus, if we divide by 2 here, we get a half cos x greater than or equal to 1 over 2. Now you may ask a question and say, but why do you divide by a 2? Remember, we got a clue that 30 degrees is a special angle. It's an SPA. Now if we want to create this back, because we know this is related to one of these graphs, and once we see root 3, we know that it has something to do with the sine 30 degrees. So that is the clue. So the clue is in the question. So if you didn't understand the question, you wouldn't know that you need to divide by 2. Remember, in maths we can divide by anything of our choosing as long as we are strategically using it to get to the solution. Now what do we see? We can reconvert this. Remember, if we moved forward, we move backward. What does this remind us of? This reminds us of a sine of 60 degrees. Okay, but now we don't have 60 degrees in our graphs here per se. Yes, there is 60 degrees, but in our functions we didn't see sine 60 written. So now this means we need to avoid that. What else gives us this? Is sine of it's a cos of 30 degrees. So we can use this as a cos. We can start with a sine and say this is sine x times cos 30 degrees plus, now we can start with the cos x, then a half was as good as sine 30 degrees greater than or equal to a half. So we reverse everything. Remember, we always do reverse operations or the so-called inverse operations. Now we can see that, well, this is an identity of sine, so we can reduce it. First angle, second angle. We can see now this is nothing but the graph of g. So this implies g of x must be greater than or equal to a half. So we can see that, okay, g of x is a half at 0, but where else is it a half? Right here. But now what is that point? Well, it's not a big deal. This is very easy. If this is a half at 0, we know that at exactly a period of 90 degrees, right? Because every point repeats itself. What am I saying? I'm lying now. So yeah, I almost got you guys poison. Okay, let's not give you guys poison. Actually, I didn't want to go beyond 20 minutes, but I'm worried now. I'm doing it. Okay, now g of x, this is the graph of g. So this is this point. Question is, what is that point? Okay, just a moment. My pot is burning. Okay guys, I'm back. So what are we going to say? We ask ourselves, if this was a half there, but I mean, there's not really much we can say. We know that the graph of sine is symmetrical, but let's leave the symmetry and all that, because I mean, if this is, think of a parabola, we know that this is going to be more like the middle. So whatever that is, if we moved 60 degrees to here, we should move 60 degrees to that other point, because this is a line of symmetry between these segments, okay, up until we hit the x-axis, and then we do it also on that side. So essentially you can think of it that way. So this is already giving the vibes of 120 degrees. But here's the best way. We say, where is this point? Can you see this point is between 90 and 180? This is the second quadrant. So when is sine a half in the second quadrant? Exactly at 150. Because 150 is 180 minus 30. We reduce that, it's a sine of 30, therefore it becomes a half. But remember, this was shifted 30 degrees early, or to the left. So 150 minus 30 gives us 120. So that is the one. That is the one. So we can say, therefore, we understand that x must be less than or equal to 120 degrees, greater than or equal to 0 degrees. Because we can see this graph is either a half or greater than a half in between. And that's the solution. Alright guys, so this is it. I hope you've enjoyed the video, and definitely we are going to get somewhere. So truly guys, what is important here is essentially this: whenever we use reduction formula, we get a mark, right? Right, and then we get a mark for these two, usually that's how we get it. So we've got 3 marks. Now of course, using our special angles here eventually gives us an extra mark. So this is how we score those 4 marks for a total of 8 marks. As you can see, this is an area where one can just come and pick those marks and run away in peace. So this means if you get boxed by any of the other questions that you probably thought you had a chance on, you can come and chill on trig functions. They are usually very easy. Yes, there may be a question like the last one, but again, if you understand maths and you have seen the summary of my video on paper 2 2024, you should be in a good position. Otherwise guys, Merry Christmas. I'll see you again next time. Goodbye.